Hello there, and welcome. I'm glad you found your way here tonight. Maybe your day was long and full, or maybe you simply enjoy the quiet comfort of drifting off while hearing about distant worlds. Either way, let yourself rest, let your shoulders loosen, your breathing soften, and your mind open like the slow unfolding of the stars. Tonight, we're not traveling through the spiral arms of our galaxy, but to one small red world that orbits nearby. A planet of dust and silence, a desert in the sky. Tonight, we journey to Mars. It hangs in our night sky like a faint ember, glowing rusty orange, steady among the stars. From Earth, it looks small, but through a telescope its world reveals itself, a globe marked with dark patches and pale caps, sometimes streaked by golden haze. Mars is not far by cosmic standards. At its closest, less than 60 million kilometers away, a neighbor just beyond Earth's orbit. And yet, despite its nearness, it remains a place of mystery, ancient and remote, holding secrets beneath its red dust. The color that makes Mars so distinct comes from iron. Its surface is coated in fine grains of iron oxide, rust that paints the deserts crimson. Every rock, every dune, every horizon carries that rusty glow. Long ago, perhaps billions of years ago, Mars may have been gray or dark like basalt, the rock of cooled lava. But time, air, and water reacted with the minerals, oxidizing them into the powdery dust that now covers the planet in a blanket of red. The entire world, from its tallest volcano to its deepest canyon, is dusted in this oxidized memory of water and air. Mars is smaller than Earth, about half the diameter, with only a tenth of its mass. Its gravity is weak, just a little more than a third of what we feel here. If you were to stand on Mars, you would feel lighter, as though your body had shed invisible weight. A 100-kilogram burden on Earth becomes only 38 on Mars. Your steps would carry farther, your leaps higher. This weaker pull is why Mars could never hold on to a thick atmosphere for long, why its sky is thin and fragile compared to ours. That sky, when you look upward from the Martian surface, is not blue, but pale and butterscotch, tinted by the ever-present dust. During sunsets, the horizon turns an eerie shade of blue as light scatters through the fine particles. It is a world reversed from ours. On Earth, our daytime skies are blue and sunsets red. On Mars, the day is a tawny gold and twilight glows faintly azure. The same physics, scattering light through air and dust, but with a different palette of colors, as though Mars chose its own mood from the cosmic spectrum. Mars spins with a rhythm familiar to us. A Martian day, called a sol, lasts just over 24 hours and 39 minutes. Almost the same as here. If you lived there, your days would not feel alien. The sunrise and sunset would follow nearly the same cadence. You would wake beneath pale skies and rest beneath cold stars in a cycle that echoes Earth's own. It is a rare comfort in an otherwise foreign world, a rhythm that says, you are still at home, even here. But the year is long. Mars orbits the Sun at a greater distance, circling once every 687 Earth days, nearly twice the time of our seasons. Spring, summer, autumn, and winter linger there, each stretched over many months. The tilt of Mars's axis is close to ours, about 25 degrees, which means it too has seasons. Ice builds at the poles, then retreats. Carbon dioxide freezes and thaws. Dust storms sweep with the shifting winds. Mars, like Earth, leans and turns in a dance of seasonal change, though colder, slower, and more austere. If you were to look at its poles, you would see caps of gleaming white shining against the rust-red land. These are layers of frozen carbon dioxide and water ice. In winter, the carbon dioxide from the air freezes, expanding the cap. In summer, it sublimates back into gas, thinning the ice and filling the atmosphere again. Beneath the topmost frost lies buried water ice, locked away for ages, layered like rings of a tree. The poles of Mars are records of climate, stacked layer upon layer, each one holding whispers of past winds and ancient snows. The air itself is almost nothing. The atmosphere of Mars is less than 1% the thickness of Earth's, and it is made mostly of carbon dioxide, with only faint traces of nitrogen and argon. To breathe there would be impossible without a suit. Not enough oxygen, not enough pressure. Yet this thin veil of gas still shapes the world. It carries dust across the planet, drives storms that can engulf continents, and scatters light into golden haze. It is a fragile sky, but it has sculpted Mars for billions of years, carving dunes, polishing rocks, and moving grains, one by one in a slow, restless wind. There is a silence to Mars, one we can only imagine. No trees to rustle, no rivers to flow, no birds to cry. Just the whisper of dust grains shifting, the faint hiss of thin winds, and the occasional rumble of quakes deep within the crust. It is a silence so complete that our rovers have sent back recordings, soft breezes brushing microphones, gentle vibrations echoing through their frames. These sounds are delicate, almost ghostly, and they remind us that even in silence, a world has a voice. Mars has been a place of imagination for centuries. To the naked eye, it is the brightest red light in the heavens, wandering across constellations with the slow dance of a planet. Ancient astronomers saw it as a god of war, a fiery wanderer, unpredictable and fierce. Its red color seemed to speak of blood and fire, of conflict and passion. Every culture gave it names tied to strength and danger. Yet the more we learn, the more that fiery point becomes not a symbol of war, but a fragile desert, quiet and vulnerable, glowing softly in the night sky. And as you let yourself drift tonight, think of this nearby world, a neighbor in orbit, a red light that has traveled with us through all of human history. It has seen our ancestors gaze upward in wonder, and it waits still, silent for our steps. The desert planet, the ember in the dark, spinning slowly, quietly, endlessly. Beneath that quiet sky, the surface of Mars tells a story written in stone and scar. It is a record of volcanoes that once roared, rivers that once carved valleys, and impacts that shattered its crust in fire and dust. The planet is old, nearly as old as Earth. But unlike Earth, it has not erased its past with oceans and tectonic plates. Its surface is a museum of billions of years, preserved in craters and ridges that whisper of ancient cataclysms. To walk there would be to step across the pages of a history book as vast as time itself. One of the most breathtaking landmarks on Mars is Olympus Mons. It is the tallest volcano in the solar system, rising over 22 kilometers high, nearly 3 times the height of Mount Everest. Its base stretches so wide across the land that if you stood at one edge, the horizon would curve before your eyes, and you would not even see the other side. This mountain is a shield volcano, built from countless flows of lava that spread outward like layers of cloth over millions of years. Unlike Earth's shifting crust, the crust of Mars did not move beneath it, so the same hotspot of magma fed Olympus Mons again and again, piling it higher until it became a mountain so vast it could cover entire countries. But even Olympus Mons is silent now. Mars no longer has the heat and convection that drive eruptions on Earth. Its heart has cooled, its volcanoes slumbering for ages. Yet their immense shapes remain, frozen monuments to a fiery youth. To imagine the red sky lit by glowing lava fountains, the plains flooded by molten rock, is to glimpse a Mars that no longer exists, a world alive with fire. If Olympus Mons is a monument to fire, then Valles Marineris is a monument to fracture. It is a canyon system that stretches more than 4,000 kilometers long, about the width of the entire United States. and plunges as deep as 7 kilometers. The cliffs of Valles Marineris rise higher than the Himalayas, and its valleys are wide enough to swallow whole cities. This canyon was not carved by a single river like Earth's Grand Canyon. Instead, it is thought to have formed as the planet's crust cracked and pulled apart, tearing open a wound across its face. Landslides and erosion deepened it, leaving behind a scar so immense that if you were orbiting Mars, it would dominate the view of the planet's surface. Between these mountains and canyons lie plains pocked with craters, each one a mark of cosmic impact. Some are small and sharp, recent craters from meteors that struck within the last few million years. Others are ancient, their edges softened by wind and dust, reminders of the violent early solar system when Mars, like Earth, was bombarded with debris. The largest is Hellas Planitia, a basin over 2,000 kilometers across and nearly 9 kilometers deep. Standing on its floor, the walls would rise above you like distant mountains, curving along the horizon. It was formed by an asteroid strike so powerful that it reshaped the entire region, creating a depression vast enough to alter the weather around it. The surface of Mars is not smooth. Dunes ripple across plains, shaped by winds that sweep the dust in patterns. Yardangs, streamlined ridges of rock, stretch across the desert, carved slowly by endless sandblasting. There are valleys and channels that twist like dry riverbeds, some stretching hundreds of kilometers, evidence that water once flowed with power. Some channels end in deltas, fans of sediment that speak of lakes that once filled basins. Though dry now, their shapes tell us with quiet certainty, once Mars had rivers that ran across its surface, carrying life-giving water from highlands to seas, and what seas they must have been. The northern plains of Mars are low and flat, stretching wide enough that many scientists believe they may once have been covered by a vast ocean. Ancient shorelines have been traced along ridges and boundaries as though waves once lapped gently at Martian beaches. Today, those seas are gone, vanished into ice and thin air, but their outlines remain carved into the memory of the land. It is as if the ocean whispered across the sand and then withdrew, leaving behind only the shape of its song. Mars's geology is also shaped by its volcanoes. Beyond Olympus Mons, the Tharsis region, a bulge of land near the equator, is home to a cluster of giant shield volcanoes, each nearly as tall as Mount Everest. Arsia Mons, Pavonis Mons, Ascraeus Mons, names that echo the quiet grandeur of these mountains. Together, they form a volcanic province, so massive it may have warped the planet itself, shifting its crust and altering its tilt. To imagine the Tharsis rise glowing with eruptions, lava rivers flowing into the plains, is to picture a Mars in the height of its geological youth, restless and alive. Yet now, that youth has passed. The planet's core cooled, its magnetic field faded, and its volcanoes went quiet. Without tectonic plates, the crust stiffened, and the great forces of renewal ended. What remains are frozen landscapes, preserved in silence, like paintings that never fade. Mars is a world that shows us not only what it is now, but what it once was, and perhaps what Earth could one day become, if time were allowed to still its fire. Every rock, every ridge, every canyon tells a story, and as you drift deeper into this quiet journey tonight, think of these landscapes. Imagine standing on the rim of Valles Marineris, looking into a chasm so deep and wide, it feels endless. Imagine walking across the gentle slopes of Olympus Mons, climbing a mountain where the air is thin, the sky pale, and the horizon curves away into red silence. Mars is not just a planet, it is a diary of fire and fracture, written in stone and left open beneath a golden sky. Above those frozen volcanoes and ancient canyons lies a sky that is delicate and strange. On Earth, our atmosphere shields and softens us, wrapping the planet in a thick blanket of air. On Mars, that blanket is threadbare, The pressure at the surface is less than 1% of Earth's, so thin that water cannot stay liquid for long. It would either freeze into ice or boil into vapor, vanishing almost as soon as it touched the ground. The Martian air is not nothing, but it is fragile, like a veil that hides more than it protects. This air is made mostly of carbon dioxide, with small traces of nitrogen and argon, and only the faintest whisper of oxygen. To us, it is unbreathable, toxic even. Yet, it is enough to shape the climate in subtle ways. Carbon dioxide freezes out at the poles in winter, then sublimates back into gas in summer, shifting pressure across the planet, driving winds and currents. The sky may be thin, but it still moves, still carries weather across the rusty plains. One of the most striking features of the Martian climate is its dust. The surface is coated in grains, so fine they can be lifted by the gentlest winds. These particles scatter light, tinting the sky in hues of butterscotch and copper. They creep into craters, cover rocks, and stain everything in their reach. Sometimes, a dust devil spins across the land, a twisting column of grit that rises into the air and dances across the desert. Rovers have captured them, thin spirals drifting silently over the horizon, painting temporary scars in the soil. But at times, the dust is not gentle. Every few years, storms grow larger, sweeping across continents, then enveloping the entire planet. The sky darkens, the sun dims, and the horizon disappears in a glowing haze of iron-red particles. These global storms can last for weeks or months, coating solar panels, burying landscapes, and reshaping dunes. They are not violent in the way storms on Earth are. The air is too thin to carry that kind of force. But they are overwhelming in scale, wrapping the planet in a cocoon of dust until it seems to vanish from view. Despite its thinness, the atmosphere of Mars gives rise to seasons that are hauntingly familiar, yet distinctly alien. The tilt of its axis, similar to Earth's, means that its hemispheres lean toward and away from the sun over the course of its long year. Polar ice caps wax and wane, releasing carbon dioxide and shaping winds. In the spring, frost thaws and strange geysers erupt from beneath translucent ice as gas builds pressure and bursts free, carving dark fans and spider-like patterns into the land. These features, called spiders, are unique to Mars, sculpted by a dance of ice, sunlight and gas that could not occur anywhere else. The temperatures on Mars are cold, far colder than our own Earth. On an average day, the surface may warm to just a few degrees above freezing in the sun, but plunge to -60 degrees Celsius at night. Near the poles in winter, it can fall below -100. And yet, in rare places at rare times, the surface temperature can rise high enough that ice might melt, if only for a moment. These fleeting instants of warmth may be hints of what once was, a climate less harsh, more welcoming to rivers and seas. The winds of Mars, though gentle compared to Earth's, have great reach. They sculpt dunes into shifting waves, some crescent-shaped, others stretched into long ridges. Over time, dunes migrate across the plains, moving meters each year. Rocks become polished, etched with delicate grooves, where sand has carved them grain by grain. The planet is restless even in silence, its thin breath carrying dust in endless cycles across its deserts. Though the atmosphere is faint, it holds clues about Mars's past. Isotopes of gases reveal that the planet once had a thicker atmosphere, one that may have supported liquid water on its surface. Over billions of years, much of it escaped into space, stripped away by the solar wind after Mars lost its magnetic field. The planet was once shielded, like Earth, but when its core cooled and the magnetic field faded, the sun's particles swept the atmosphere away, leaving behind the thin ghost of air we see today. Yet this thinness has beauty. Sunrises glow softly, the light scattering into delicate hues of blue at the horizon, while the higher sky remains golden. Sunsets reverse the palette, with the fading sun surrounded by an azure glow, as the rest of the sky deepens into copper. To stand there would be to see a sky both familiar and reversed, a mirror of Earth's, a reminder that the laws of physics are constant, but the colors they paint depend on the canvas. And when night falls, the thin air cannot hold heat. The land cools rapidly, radiating warmth into the vastness of space. The stars blaze sharper in that cold clarity, untouched by haze or moisture. The moons of Mars, Phobos and Deimos, rise and set quickly, tiny lopsided shapes against the black, and beyond them, Earth itself can sometimes be seen as a bright star, a pale blue dot shimmering in the Martian sky. For a traveler there, Earth would be just another star in the night, a distant light marking home. So let yourself drift with the winds of this thin air, light as whispers, carrying dust across valleys and plains. Imagine the blue glow of a Martian sunset, the world wrapped in butterscotch sky, and the silence of a planet that breathes in storms but speaks in whispers. Mars is not only a world of stone and ice, but of air and light, fragile and strange. A place where the atmosphere is thin, but the stories are deep. If stone and dust record the body of Mars, then water tells us of its soul. On Earth, water is everywhere: oceans, rivers, clouds, and rain. On Mars, it is almost gone, a ghost of its former self, lingering only in hints and traces. Yet these traces are powerful. They tell us that Mars was not always a frozen desert, but once, long ago, it was a world of flowing rivers, deep lakes, and perhaps even a wide ocean, stretching across its northern plains. Evidence of water is etched into the land itself. Dry river valleys cut across the highlands, winding channels that twist and branch like veins on a leaf. These valleys are not the work of lava or wind, but of liquid water flowing downhill. Some are narrow and delicate, carved by trickles that once seeped across the soil. Others are massive, carved by floods so violent they could have drained entire lakes in a single surge. Standing at the edge of such a channel, you would see a dry scar today, but its shape is unmistakable, the signature of water that once rushed with force. In craters and basins we see the remains of deltas, fans of sediment deposited where rivers once emptied into still lakes. These features are among the strongest signs of ancient water, for deltas form only when liquid flows steadily into a body of standing water. Layer upon layer of sediment fans outward, freezing the memory of a shoreline that is long gone. Rovers like Curiosity have studied such deltas in Gale Crater, finding fine grains and clays that could only have formed at the bottom of a calm lake. For billions of years those rocks have held their secret, until our machines touched them and read their story. The most haunting possibility is that Mars once had an ocean. The northern lowlands are vast and flat, lying below much of the rest of the planet. Their boundaries trace lines that resemble ancient shorelines, as if waves once marked the edges of a sea. If it existed, this ocean may have covered millions of square kilometers, a true northern hemisphere sea. Its waves would have reflected a sun that shone warmer in that young sky, and its shores may have carried the same salt-laden breezes that we know from Earth's coasts. Though the sea is gone, the land still carries its outline, whispering that Mars was once blue. Even today, water remains, though it is locked away. At the poles, it hides beneath layers of frozen carbon dioxide, forming caps of shining ice that grow and shrink with the seasons. Beneath the surface, ice lurks in the soil. Just centimeters below in some places, rovers have scratched into the ground and uncovered bright patches that slowly faded as they sublimated into the thin air. This ice lies buried across wide regions, a frozen reservoir spread like treasure beneath the dust. Deep underground, there may be more still. Radar scans from orbiting spacecraft have suggested pockets of liquid brine beneath the polar caps, water mixed with salts, kept from freezing by chemistry and pressure. If real, These buried lakes would be the only liquid reservoirs of water still on Mars today, hidden beneath kilometers of ice. They would be dark, cold, and silent, untouched for millions of years. If life still lingers anywhere on Mars, these secret waters may be where it hides. Water also shapes the atmosphere in subtle ways. Frost forms in the mornings, coating rocks with a fragile sheen that vanishes in the sun. Wisps of ice clouds drift across the thin sky, especially near the poles. Delicate veils of frozen vapor high above the land. Sometimes fog fills valleys, rolling softly through canyons before lifting in the light. These are small things, fleeting moments, but they remind us that Mars is not entirely dry. It still breathes water in whispers, in mists, in thin, frozen films. Rovers have found minerals that could only have formed in water: clays, sulfates, hematite spheres scattered like tiny marbles. Each mineral is a record of chemistry, shaped when rocks met liquid and altered over time. They are not random, they are specific, testifying to a past where water was common enough to change the face of the land. These minerals are the memory of Mars's wet past, preserved in stone even as the surface dried and froze. And then there are the gullies. On crater walls and slopes, channels have been spotted that look fresh, sharp, and recent. Some scientists believe they may have been carved by small amounts of liquid water, brines that seeped briefly before evaporating. Others argue that dry processes can explain them, but whether water flows today or not, the very fact that we still debate it shows how alive the question remains. Water on Mars is not just a story of the past, it is a mystery of the present. When we look at Mars today, we see a desert, but beneath that desert lies the shadow of rivers, seas, and storms. Imagine standing on its plains billions of years ago, watching water flow past your feet, hearing waves lap against a shoreline. Imagine rain falling through a thicker sky, clouds gathering and breaking in storms. That world is gone, but its memory is etched everywhere, in valleys, deltas, minerals, and ice. As you drift further into rest, think of Mars as a world with two faces: the dry, frozen desert we see today, and the blue planet it once may have been. Both are real, layered together in the rocks and dust. Mars is a reminder that even worlds can change, that time reshapes everything, turning seas into deserts, rivers into valleys, and water into ice. It is a story of loss, but also of endurance, a quiet record kept in stone and silence. If water is the key to life, then the story of Mars is inseparable from the question of whether it was ever alive. For as long as humans have looked at the red planet, we have wondered not only about its landscapes, but about its inhabitants. From myths of fiery gods to visions of canals and civilizations, Mars has long been a canvas for our imaginations. And yet, beneath those dreams lies a scientific question, as deep as any. Did life ever find a foothold here? And could it still remain hidden in the shadows of stone and ice? On Earth, wherever water flows, life follows. In the depths of oceans, around volcanic vents, in the frozen soils of Antarctica, even in the driest deserts, microbes cling to existence. These extremophiles thrive in environments once thought uninhabitable. Their resilience shows us that life does not demand comfort, only opportunity. And if Earth's microbes can survive in freezing salt lakes, acidic springs, or beneath barren rock, then why not on Mars, long ago when rivers flowed and seas spread wide? The surface today is harsh. Cosmic radiation streams through the thin atmosphere, ultraviolet light burns unshielded, and temperatures plunge far below freezing. To survive here, life would need protection. Beneath the soil, under ice, or within rock. That is why scientists search for subsurface niches, places where brines might persist, where microbes could lie dormant, shielded from radiation. Mars may look lifeless from above, but beneath its crust, tiny worlds of possibility may still exist. Rovers and landers have searched tirelessly for clues. Viking, in the 1970s, carried experiments designed to test for life in Martian soil. The results were ambiguous, sparking decades of debate. Later missions have focused on finding the ingredients for life: organic molecules, water, energy sources. Curiosity rover drilled into ancient rocks and detected organic compounds, not proof of life, but proof that the building blocks were present. Perseverance rover now gathers samples in Jezero crater, a place where a river once met a lake, storing sediments that may hold fossils of microbial life, if any ever existed. Those samples, waiting to be returned to Earth, may one day give us the answer. But even now, the hints are tantalizing. Methane has been detected in the Martian atmosphere, sometimes spiking unexpectedly. On Earth, much of our methane is produced by microbes, though it can also arise from geological processes. On Mars, we don't yet know the source. The fact that it appears, lingers, and fades suggests active processes, something, whether chemical or biological, is shaping the air even now. Each whiff of methane is a whisper that the story of Mars may not yet be finished. If life did exist here, it may have begun early, when Mars was warm and wet, perhaps even before Earth fully settled into stability. Small cells could have formed in lakes, sheltered in hydrothermal vents, or floated in salty seas. Perhaps they thrived for millions of years before the planet grew colder and drier, retreating underground as the surface froze. Or perhaps life never began, and Mars remained only a stage set for a story that never played. Either way, the rocks hold the truth, waiting for us to learn how to read them fully. Some scientists imagine that Mars and Earth may even share a connection. In the early solar system, asteroids struck both worlds frequently. Debris from Mars has been blasted into space, and pieces of Martian rock have landed on Earth, carrying with them ancient minerals and gases sealed inside. If life ever existed on Mars, it could have traveled to Earth on such meteorites, or perhaps the reverse, Earth seeding Mars with microbes in those violent exchanges. In this way, our two worlds may be bound not only by gravity, but by biology, sharing invisible threads of possibility across the void. Yet even if Mars is sterile today, its silence has meaning. It teaches us about limits, about how fragile the conditions for life truly are. It shows us what happens when a planet loses its magnetic shield, its thick air, its flowing water. It becomes a desert, a world of stone, and in that silence lies a mirror, a warning and a lesson for us, who live on the only planet known to carry life. But perhaps it is not silence, after all. Perhaps beneath the ice, in pockets of salty water, tiny microbes still drift, metabolizing slowly, waiting for warmth. Perhaps fossils lie locked in rocks, waiting to be uncovered by rovers or by the hands of future explorers. The story of life on Mars has not been written in full, only hinted at, whispered through minerals, gases, and ancient shapes. As you let your breathing slow, imagine those whispers, the possibility that we are not the first life to touch Mars, nor the only. Imagine standing at the edge of Jezero crater, running your hands across stones laid down in an ancient river delta, stones that may have once touched living things. And whether they did or not, Mars still teaches us to listen, to search, to wonder. For in the silence of its deserts lies the most profound of questions. Are we alone, or are we only one branch of life's long cosmic tree? Orbiting above the red deserts of Mars are two tiny companions, strange and silent, unlike the grand round moons we know from Earth. Their names are Phobos and Deimos, fear and dread, drawn from the horses that pulled the chariot of the god of war. They are not bright, not large, not even round. They are lopsided worlds, potato-shaped and scarred, so small that they barely hold themselves together. Yet they circle Mars faithfully, casting their shadows across its surface, marking the planet's sky with restless motion. Phobos, the larger of the two, is still only about 22 kilometers across. From the ground on Mars, it would not look like our moon looks to us. Instead, it would appear as a lumpy, rushing shape that crosses the sky in less than 4 hours. It orbits so close to Mars that it rises in the west and sets in the east, racing overhead multiple times in a single Martian day. No other moon in the solar system orbits so near to its planet. Its closeness makes it seem urgent, like a restless thought that never leaves the sky. Deimos is smaller still, only about 12 kilometers across. It orbits farther out, moving slowly, rising in the east and setting in the west, like our own moon. From Mars, Deimos would look like a bright star drifting across the sky, almost too small to cast shadows. Where Phobos feels heavy and ominous, Deimos feels delicate, a faint spark keeping its distance. Together they form an odd pair, one rushing, one drifting, both bound in orbit around a silent world. Neither moon is a perfect sphere. They are irregular, shaped by impacts and rubble. Their surfaces are covered in craters, some so large that they nearly split the moons apart. Phobos in particular carries a massive scar called Stickney crater, a wound so large relative to its size that it dominates one entire face. Around it, grooves and cracks stretch like fractures, as though the moon was nearly shattered and barely held together. Every orbit, every stress of gravity pulls at those fractures still. These moons are small, and their gravity is faint. On Phobos you could leap into the air and never return, drifting slowly into the void with the gentlest push. Even walking would feel strange, each step so light that you might float above the surface. They are not worlds to stand on easily, but fragments of stone suspended in orbit, more like drifting asteroids than true moons. And in fact, that may be what they are. Captured asteroids from the outer solar system pulled into orbit by Mars's gravity long ago. But their origins are still debated. Some scientists think they are captured, wandering rocks drawn in from the asteroid belt. Others argue they may have formed from debris, rubble left over from a massive impact that once struck Mars, flung into orbit, and slowly coalescing into small moons. Their compositions hold clues. Phobos and Deimos are dark, covered in material rich in carbon, similar to some asteroids. But their exact nature is uncertain, and so they remain mysteries, fragments that hint at both capture and creation. Phobos, rushing closest, carries a fate unlike any other moon. It is slowly spiraling inward, its orbit decaying, as Mars's gravity pulls at it. In perhaps 50 million years, it will either crash into Mars or be torn apart into a ring of debris. If torn apart, Mars may one day wear a temporary crown of rings, glowing faintly in the red sky before the fragments eventually rain down. Phobos is a doomed world, but its doom is slow, unfolding on timescales far beyond our own lives, a quiet inevitability written in its orbit. Deimos, on the other hand, drifts away, like our own moon around Earth. It is slowly receding, inch by inch, carried outward by orbital tides. Where Phobos will fall, Deimos will escape, a faint spark that one day may drift free of Mars entirely. The fates of these two moons mirror their names. Phobos pulled downward into ruin, Deimos fleeing into distance, a balance of fear and dread, each carrying its destiny in silence. From Mars, eclipses caused by Phobos are common. The small moon often passes in front of the sun, covering it not with totality, but with a lumpy silhouette that sweeps across the sky. These partial eclipses are fast, only seconds long, but they remind us that even small moons can play with shadow and light. From the surface, watching Phobos race across the sun would be a strange sight, like a pebble skipping quickly across a glowing pond. Though small, these moons matter. They affect Mars's tides, subtle though they are in its thin atmosphere and frozen soils. They hold clues about the history of the solar system, about impacts, captures, and the restless exchange of material between planets. And one day, they may serve as stepping stones for explorers. Phobos, with its low gravity, could be a natural outpost, a platform for studying Mars below. Its surface could hold resources, its orbit a gateway. These moons may be tiny, but they are not silent in their story. So as you drift deeper into rest tonight, imagine looking up from Mars' deserts. Phobos races overhead like a restless thought. Deimos drifts softly like a dream, and together they keep Mars company. In its long orbit around the Sun, they are small, fragile, and fated. But in their quiet dance, they remind us that even the tiniest worlds can hold mystery, beauty, and meaning. For centuries, Mars was known only as a wandering point of light, a reddish ember crossing the constellations. Ancient astronomers tracked its strange motion, sometimes moving forward, sometimes backward in the sky, and saw it as a restless traveler. Unlike the fixed stars, its red glow gave it power in myth, tied to gods of war, passion, and fire. Yet it was not until the invention of the telescope that humanity began to glimpse Mars as a true world, not just a moving star. In the 17th century, Galileo turned his small telescope toward the planet and saw little more than a tiny disk. But even that was enough to prove that Mars was a world, not just a point. As telescopes improved, astronomers began to notice markings, dark patches, pale regions, and bright caps at the poles. They thought they saw seas and continents, clouds and seasons, and for the first time, they imagined Mars not just as a planet, but as a possible Earth-like world. In the 19th century, Giovanni Schiaparelli sketched networks of dark lines across Mars, calling them canali, channels. When mistranslated into English as canals, the idea of intelligent life constructing them took hold. Percival Lowell popularized this vision, imagining a dying world where a desperate civilization built canals to carry water from the poles across the deserts. For decades, Mars was seen as a planet of engineers, of advanced beings clinging to survival. Though the canals were illusions of optics and imagination, they captured the human mind and spirit, shaping stories and dreams. When spacecraft finally reached Mars, the truth was both harsher and more beautiful. In 1965, NASA's Mariner 4 flew by and sent back the first close-up images. The pictures revealed a surface scarred with craters, dry and barren, more like the moon than the Earth. The vision of green fields and canals collapsed overnight. Mars was not lush, but stark. It was a desert world, silent and cold. For some, it was a disappointment. But for others, it was a beginning, a truth deeper than myth, more haunting than fantasy. Later missions expanded the picture. Mariners 6 and 7 confirmed the barren land, while Mariner 9, in 1971, became the first spacecraft to orbit another planet. It arrived during a global dust storm, and at first, all it saw was haze. But when the storm cleared, it revealed towering volcanoes, immense canyons, dried riverbeds, and polar caps of ice. The Mars that emerged was not dead, but complex. A world that had once been alive with geological power, and perhaps with water. The myths of canals had faded, but a new, richer story began to unfold. In the decades that followed, missions brought us closer. Viking 1 and Viking 2, in 1976, became the first to land on Mars and send images from the surface. Their cameras showed rocky plains beneath a salmon-colored sky, with horizons that looked strangely familiar and alien at once. The Viking landers also carried experiments to test for life in the soil. The results were inconclusive, chemical reactions that could be explained by both life and lifeless processes. To this day, those results spark debate, lingering like whispers in the dust. Mars became not just a subject of astronomy, but a place we could visit with machines, a landscape we could touch with robotic hands. Each mission revealed more detail: craters eroded by wind, rocks shaped by ancient floods, frost sparkling on the surface. Each landing felt like a step into another world, a place that seemed distant but was now within reach. Mars, once only a light in the sky, was now a place where our machines could rest, breathe, and look around. And all along, telescopes on Earth continued to watch. In clear skies, they saw storms grow and fade, ice caps wax and wane. They tracked its rotation, its seasons, its shifting weather. The Hubble Space Telescope sent back images of the whole globe: clouds drifting above rusty plains, storms forming in white arcs across the poles. Mars became not only a scientific subject, but a world of weather reports, maps, and forecasts, a neighbor that we watched as if it were another country across the sea. Through these centuries of watching, imagining, and arriving, Mars has grown in our minds. It is not the green world of myth, nor the lifeless sphere of early disappointment, but something deeper, a planet of stories, written in stone, air, and time. We learned that it is colder, harsher, and quieter than we once dreamed. Yet we also learned that it carries rivers, volcanoes, and mysteries of life. It is both barren and full of promise, a mirror that reflects our own desire to search, to know, to wonder. So as you rest tonight, picture the journey of our gaze, from ancient stargazers tracking its path, to Galileo's first blurred glimpse, to spacecraft that now rest on its soil. We have walked with Mars in imagination and in truth. It is no longer just a wandering ember in the night. It is a world of canyons, craters, and storms, waiting for us to uncover more of its quiet story. When the 20th century gave way to the 21st, Mars became more than a mystery. It became a place we could visit not just briefly, but for years at a time. Spacecraft began to circle it continuously, mapping its surface with precision, peering through dust and haze, and uncovering secrets hidden in stone. Rovers rolled across its plains, leaving tracks in the sand, drilling into rocks, and sending back voices of a world that had waited in silence for billions of years. The age of close exploration had begun. Orbiters became our eyes in the sky. Mars Global Surveyor, Mars Odyssey, Mars Express, and the Mars Reconnaissance Orbiter circled the planet, sending back detailed maps of its canyons, craters, and volcanoes. High-resolution cameras revealed boulders the size of cars, dunes shifting with the winds, and cliffs layered like pages of a book. Radar instruments probed beneath the surface, finding ice hidden underground. Spectrometers identified minerals formed in water. Orbiters showed us Mars not as a vague globe, but as a living atlas, a world we could read in detail from orbit. On the ground, rovers brought Mars closer still. In 1997, Pathfinder's tiny rover Sojourner became the first to drive on another planet. It was small and simple, the size of a microwave, but it proved that wheels could roll across alien soil. Its images showed a stony plain beneath a dusty sky, rocks scattered like the remnants of an ancient flood. For the first time, Mars was not only seen from above, but explored step by step. Then came Spirit and Opportunity in 2004, twin rovers that were meant to last only 90 days. Spirit journeyed through the rugged hills of Gusev Crater, discovering signs of past hydrothermal activity. Opportunity traveled far across the Meridiani Plains, finding hematite blueberries that hinted at watery pasts. It drove for years, far beyond its planned mission, covering over 40 kilometers. When a storm finally silenced it in 2018, it sent one last message. Its battery was low, and the sky was dark. For more than 14 years, Opportunity spoke for Mars, and its silence was like the closing of a long, tender chapter. Curiosity followed, landing in Gale Crater in 2012, with a dramatic descent that used rockets, and a sky crane to lower it gently to the surface. This car-sized laboratory carried drills, lasers, and instruments to study rocks in exquisite detail. It discovered ancient lake beds, minerals formed in water, and organics preserved in stone. It sniffed the air for methane, finding fleeting traces that still puzzle scientists. Curiosity is still there today, climbing the slopes of Mount Sharp, a layered mountain at the crater's center, reading its rocks like a library of climate and water. And now, Perseverance explores Jezero Crater, a place where an ancient river once spread into a delta. It searches for signs of microbial life that may have lived in those waters long ago. It drills cores of rock, seals them into tubes, and leaves them on the surface for a future mission to bring back to Earth. Alongside it, a tiny helicopter named Ingenuity has flown dozens of times, the first machine ever to fly in the sky of another planet. With each flight, it proves that even in the thin Martian air, wings can lift and glide. Ingenuity was meant to fly only a handful of times, yet it has far outlived expectations, scouting terrain and making history. Together, these rovers and orbiters have transformed Mars from a distant red star into a familiar landscape. We now know its canyons, its dunes, its icy caps, and its craters with the same clarity we know deserts on Earth. We have weather reports from its sky, temperature readings from its soil, and sounds of its winds whispering past robotic ears. Mars has become a place of daily updates, images that arrive every morning, discoveries that unfold quietly, but steadily. Yet even as these machines reveal so much, Mars remains silent and strange. Its air is thin, its rivers gone, its surface hostile to life as we know it. The rovers may wander, but they are alone, mechanical pilgrims in a vast and empty desert. Their tracks fade with dust, their signals cross millions of kilometers, and their eyes look out over a world that has not known footsteps. And still, the dream of footsteps lingers. With every image sent back, we imagine standing there ourselves. We picture our boots pressing into red soil, our breath fogging in helmets, our voices carried through radios. Each rover's wheel marks are like the first lines of a story we hope to continue. One where Mars becomes not only a place we visit with machines, but a place we touch with our own lives. So as you close your eyes, imagine the rovers still at work, their cameras turning toward the horizon, their instruments humming softly. Imagine orbiters circling above, watching as dust storms form and ice gleams at the poles. Imagine the helicopter's blades spinning against thin air, lifting into a sky that has never known flight before. Mars is not silent anymore. It speaks to us daily, in data, in images, in discoveries. It is a neighbor whose voice has grown familiar, even if we still have far to go. When we look at Mars, we cannot help but compare it to Earth. They are siblings of a sort, both rocky planets born from the same swirling cloud of dust and gas around the young sun. Both have mountains, valleys, deserts, and ice. Both have days of nearly the same length, tilted axes that give rise to seasons, and skies that change with weather. And yet, for all these similarities, one is alive with oceans and forests, while the other is silent, dry, and cold. To study Mars is to see another path that a world might take, one so close to ours, and yet so very different. Earth is larger and heavier, with stronger gravity that holds a thick atmosphere and oceans of water. Mars, smaller and lighter, could not keep such riches for long. Its gravity was too weak to hold on to its air when its magnetic field faded. Without that shield, the solar wind stripped its sky away, carrying molecules off into space, thinning the air until it became a whisper. With the air went much of the water, lost to space or locked away as ice. Mars became dry, not because it never had water, but because it could not protect what it once held. And yet Mars carries echoes of Earth in its landscapes. Its canyons look like the scars of great rivers. Its plains resemble dried seabeds. Its volcanoes stand taller than any on Earth. To see Olympus Mons is to see what a mountain could become if our planet did not have shifting plates to break it apart. To see Valles Marineris is to imagine the Grand Canyon stretched across an entire continent. Mars is like Earth's reflection in a distant, warped mirror, showing us what our world might look like under different rules of size, heat, and time. Even the colors speak of contrast. Earth is blue and green, alive with water and life. Mars is red and brown, a desert painted in rust. From space, the two worlds glow like opposites, one bright with oceans, the other dusty and dry. And yet, beneath that surface difference, Mars still has water frozen at its poles, clouds drifting in its thin air, and wind sculpting dunes. It is not entirely dead. It breathes in its own quiet way, even if its breath is faint. Mars also shares with Earth the rhythm of seasons. Its tilt is 25 degrees, close to Earth's 23.5. That tilt means that its poles lean into and away from the sun, creating cycles of warmth and cold. Ice builds and recedes, storms swell and fade, and the sun's path shifts across the sky. The year is longer, but the pattern is familiar. If you lived there, you would feel the passage of spring, summer, autumn, and winter, though each would stretch almost twice as long as on Earth. The seasons would be familiar in rhythm, but alien in color and temperature. For all their similarities, the most striking difference may be in life. Earth is alive everywhere, from its oceans to its atmosphere, from the deep crust to the highest mountains. Mars, if it ever had life, may have lost it long ago. Its silence is stark against our abundance, and yet, this silence makes it precious. For if we were to find even a trace of past life on Mars, it would change everything. It would tell us that life is not unique to Earth, but a natural outcome of planets. When water and chemistry align, Mars is not just a desert to explore. It is a test of one of the greatest questions we can ask. And perhaps that is why we are drawn to it so powerfully. Venus is closer, Jupiter's moons are more intriguing, but Mars calls to us in a way none of the others do. It looks like us, but not quite. It reminds us of home, but also of what home might have been without oceans and forests. Mars is familiar enough to imagine living there, but alien enough to stir awe. It is both near and unreachable, both inviting and forbidding. When we look at Mars through telescopes, through orbiters, through rovers' eyes, we are not just studying another planet. We are looking into a mirror that shows us both what we are and what we are not. Mars is Earth's twin in form, but its opposite in fate. One world is vibrant, the other silent, and in that contrast lies both warning and wonder. So as you drift further into rest, imagine Earth and Mars circling the sun together. Two siblings, one blue and alive, one red and quiet, both spinning endlessly in the dark. They are reminders that the universe holds many paths and that life, fragile and rare, may not always find the same home twice. To understand Mars is to read a history written not only in stone, but in air and ice. For the planet we see today, dry and cold, is not the planet it always was. Long ago, in the deep past, Mars may have been warmer, wetter, and more alive with change. Over billions of years, it transformed from a world with rivers and seas to the silent desert we know now. Its climate tells the story of that transformation, a story of loss, but also of resilience, of how a planet can endure even as it grows still. Billions of years ago, Mars likely had a thicker atmosphere. Its air, denser than today's faint whisper, could have trapped more heat, keeping the surface above freezing in many regions. Evidence of flowing rivers and deltas suggests that liquid water once moved freely across the land. Lakes filled craters, rivers carved valleys, and perhaps an ocean stretched across the north. Clouds may have drifted through a sky heavier than today's, rain may have fallen, and storms may have rolled across plains, now buried in dust. But that world did not last. Slowly, Mars lost its shield. Its core cooled, and with it, the magnetic field faded. Without that protection, the solar wind, a constant stream of charged particles from the sun, began to strip away the atmosphere, molecule by molecule. Hydrogen escaped first, then oxygen and carbon dioxide followed. What remained grew thinner and thinner until it could no longer hold warmth. Temperatures dropped, water froze or escaped, and the seas withdrew. Mars became the frozen desert it is today. Yet this transition was not simple. The rocks record multiple shifts, as if Mars wavered between climates. Some periods may have been colder, others warmer, with ice advancing and retreating like Earth's glaciers. The polar caps today preserve layers of ice and dust, stacked like pages in a book, recording these cycles over millions of years. Each layer is a memory of a season, a storm, or a shift in the tilt of the planet's axis. For like Earth, Mars wobbles in its tilt. Sometimes it leans more, sometimes less. And with each change, the distribution of sunlight shifts, reshaping the climate. At times of high tilt, ice from the poles may have sublimated into the atmosphere and refrozen closer to the equator, forming glaciers across the mid-latitudes. These glaciers, though hidden beneath dust today, still exist in places, buried ice fields stretching for hundreds of kilometers. They are remnants of a more recent Mars, when ice flowed across the land, carving ridges and leaving moraines like those on Earth. To see these dusty glaciers is to be reminded that Mars is not entirely frozen in time. It still breathes in long, slow rhythms. The atmosphere, thin as it is, still drives weather today. Carbon dioxide freezes at the poles each winter, reducing air pressure across the planet, then sublimates back each summer, restoring it. Dust storms rise and fade, sometimes small, sometimes fast enough to cover the globe. Temperatures shift between day and night dramatically, with swings of over 60 degrees. Mars is a desert of extremes, not just of dryness, but of change. It's thin air, allowing heat to escape quickly, leaving nights sharp and cold. Despite this harshness, the planet still shows traces of a softer climate. Minerals found by rovers suggest that some regions were once neutral in chemistry, with waters that could have been drinkable. Other regions are more acidic, harsher, but still evidence that water was present long after the great rivers dried. These chemical fingerprints tell us that Mars's climate was not only dynamic, but diverse, with pockets of habitability scattered across time. The mystery remains. How long did Mars's warm period last? Was it brief, only a few 100 million years? Or did it linger, with lakes and rivers persisting for much longer? Did the planet ever truly support stable oceans? Or were its seas frozen at the edges, thawing only in bursts? The answers are written in rocks and isotopes, in the ratios of gases still drifting in the air, in the thayer of sediment waiting for us to read them. Each rover and orbiter adds another line to the story, another clue to the shifting past of a world that changed so completely. In this way, Mars is a teacher. It shows us how fragile climate can be, how easily balance can be lost. Where once there may have been warmth, now there is cold. Where once rivers flowed, now dust fills valleys. And yet, Mars still endures. It circles the sun, its poles gleam with ice, its winds carry dust in endless motion. It is not dead, only quiet. Its climate has changed, but its presence remains. A reminder that even as worlds shift, they do not vanish. As you rest tonight, picture Mars not as it is, but as it was. Skies thicker, waters flowing, sunlight glittering on waves that no longer exist. Then picture it as it is now, a frozen desert of butterscotch skies and rust-red stone. Both are true, both are Mars, and both are written in its climate, the long memory of a planet that has lived through warmth and cold, abundance and silence, and still turns gently in the dark. Long before spacecraft revealed its deserts, Mars was alive in our minds. Its red glow drew the attention of ancient peoples who gave it names tied to fire, blood, and war. To the Babylonians, it was Nergal, a god of destruction. To the Greeks, Ares. To the Romans, Mars, the god of war himself, fierce and unyielding. In many cultures, it was a symbol of passion, conflict, and restless power, a wandering star that moved unpredictably against the constellations. To see it brighten in the night sky was to feel the presence of something fiery and alive, a spark of intensity in the heavens. Through centuries, Mars carried this aura of omen and myth. Its retrograde motion, when it appears to pause and move backward in the sky, added to its mystery, a celestial sign that seemed to defy logic. Astronomers tracked its wandering path carefully, and in doing so, Mars played a central role in shaping our understanding of the cosmos. Johannes Kepler, studying the orbit of Mars, discovered that planets move not in circles but ellipses, a revelation that helped build the foundation of modern astronomy. Mars, in this way, was not only a symbol of gods, but a key to truth. In the 19th century, with telescopes improving, Mars became a canvas for human imagination once more. Schiaparelli's canali, mistranslated into canals, sparked a vision of a planet built by intelligence. Percival Lowell embraced the idea, describing vast networks of irrigation works stretching across the globe, signs of a civilization struggling to survive on a dying world. Though no such canals exist, the idea captured hearts and minds. Mars became the home of imagined beings, engineers of deserts, a mirror for both our fears and our hopes. Science fiction blossomed from these visions. H.G. Wells imagined Martians as invaders in the War of the Worlds, descending upon Earth with superior technology. Edgar Rice Burroughs filled Mars, his barsoom, with kingdoms, warriors, and romance. Countless stories followed, each shaping Mars into something different. Sometimes a home, sometimes a threat, sometimes a stage for human destiny. Mars became not just a world in the sky, but a world of the mind, a place where we could project our own dreams and anxieties. Even as spacecraft erased the canals and civilizations, the fascination remained. Instead of disappointment, the discovery of a barren Mars opened a new kind of wonder. If there were no cities, then perhaps there had once been life hidden in the rocks. If there were no oceans now, then perhaps there had been seas long ago. The emptiness did not silence our imagination. It expanded it, shifting from fantasy to science, from Martian empires to microbes in stone. And still, Mars is everywhere in culture. It appears in novels, films, music, and art. It is the backdrop for survival stories, the dream of colonization, the stage for questions of isolation and resilience. We imagine astronauts walking its dusty plains, building domes beneath its pale skies, turning a silent desert into a second home. We imagine standing on the rim of Valles Marineris, watching the sun set in a blue haze. We imagine looking up at Earth shining as a star, knowing that home is far away, but still within sight. Mars has always been more than itself. It is a mirror of human imagination, reflecting our fears of war, our dreams of adventure, our longing to find company in the cosmos. Whether as a god, an omen, a home of alien beings, or a desert waiting for us, Mars has been with us in thought for as long as we have watched the night sky. It is not only a planet, it is part of our story, written in myth, in literature, and in dreams. And perhaps that is why it holds us so tightly still. Other worlds are larger, brighter, or stranger, but none grip our imagination as Mars does. It is close enough to feel reachable, Earth-like enough to seem familiar, different enough to feel mysterious. It is both foreign and intimate, both strange and ours. We see in it the possibility of past life, the challenge of survival, and the hope of one day leaving Earth while still staying close to home. As you let your thoughts drift, imagine the long chain of human gazes, ancient stargazers tracing its path, Renaissance astronomers unlocking its orbit, 19th century dreamers filling it with canals, and modern explorers sending machines to its deserts. Mars is not just a place in the sky. It is a place in our collective heart, a canvas that has carried our myths, our science, and our longing through centuries. The Mars we know today is silent, but in our imagination, it is alive with footsteps and voices. For decades, we have dreamed of going there, not only with machines, but with our own bodies, to stand beneath its butterscotch skies, to breathe through suits, to build shelters against the cold. The dream of Mars has always been not just about discovering the past, but about shaping the future. To set foot there is to write a new chapter in human history, one where another world becomes part of our story. In the near future, human missions may carry explorers across the void, landing them on plains where no person has ever stood. They will step down onto soil that has waited for billions of years, leaving the first footprints in dust untouched. Since before life on Earth began, they will look up and see Earth as a star, small and bright in the sky, and feel both the distance and the connection. Their presence will be fragile, surrounded by dangers, yet profoundly symbolic. For the first time, Earth will have reached beyond itself. Life on Mars would not be easy. Its air is thin and unbreathable, its temperatures deadly cold, its soil filled with toxic perchlorates. Radiation from the sun would pass through its weak sky, demanding protection in domes, caves, or thick-walled habitats. Every resource would need to be planned, recycled or mined from the planet itself. Water would be drawn from ice hidden underground, oxygen extracted from carbon dioxide, fuel manufactured from the very air. Survival would require ingenuity, discipline, and resilience. And yet, humanity has always adapted. Just as we once crossed oceans with fragile ships, we may one day cross interplanetary space to build homes on this desert world. Colonies may begin small, a few explorers in sealed habitats, growing food under lights, recycling every drop of water. Over time, perhaps greenhouses will spread, machines will draw power from sunlight, and settlements will grow into towns. Mars would remain harsh, but we would carve out a place within it, adapting its silence to our rhythm. Some dream even further, imagining not just survival, but transformation. The idea of terraforming Mars, reshaping its climate to make it more like Earth, has filled minds for generations. The vision is bold, warming the atmosphere, thickening the air, releasing frozen water, and filling the sky with clouds. With enough time and technology, some imagine Mars covered in seas again, with valleys filled by rivers and plains green with life. It may take centuries or longer, but the dream persists. It is the dream of turning a dead world into a living one. Science reminds us that this vision is vast and uncertain. The resources required are immense. The challenge is daunting. Yet even without full transformation, partial steps may be possible. Warming local regions, building domes filled with plants, creating sheltered biospheres where life can thrive. In these contained worlds, humans could walk among trees, breathe freely, and remember the forests of Earth while standing on a red desert beneath an alien sky. Mars calls to us not only because it is possible, but because it is necessary to imagine. It is a world close enough to reach, familiar enough to live upon, yet alien enough to challenge us completely. To settle Mars would mean to become more than earthbound. It would mean humanity's story stretches beyond one planet. that our survival no longer depends on a single world. In Mars lies both the challenge of hardship and the promise of continuity, that life, fragile as it is, can spread farther than its birthplace. And there is another, quieter reason. To live on Mars would be to live in constant awareness of Earth. Every time its blue star rose in the sky, settlers would be reminded of home, of oceans and clouds, forests and rain. They would look up at Earth with longing, knowing it held the cradle of humanity, but also with pride, knowing they carried that legacy farther. In this way, Mars would not replace Earth. It would honor it, a second branch of the same tree. So as you drift tonight, imagine walking across a Martian plain. The horizon stretches beneath a pale sky. Domes gleam in the distance, and the hum of machines keeps the air inside alive. Imagine the laughter of children playing in low gravity, leaping higher than on Earth. Imagine greenhouses glowing at night, plants exhaling oxygen into the recycled air. Imagine the sound of a human voice echoing across canyons that have never known speech. It is a dream, distant but not impossible. A dream that carries us beyond ourselves into a wider story. When we look at Mars, we see only its surface, the red dust, the canyons, the volcanoes, the plains. But like Earth, Mars is more than what lies on top beneath the rust-colored crust. The planet holds layers of stone and heat, a hidden architecture, shaped when it first formed over 4.5 billion years ago. Though smaller and cooler than Earth, Mars still has an interior that speaks in whispers, not with eruptions or drifting plates, but with subtle tremors, signals of what lies within. Mars's crust is thick compared to Earth's, a rigid shell that has not broken into moving plates. On Earth, tectonic plates shift and grind, creating earthquakes, mountains, and continents. But on Mars, the crust is locked. This stillness explains why Olympus Mons could grow so vast. The crust beneath it never moved, allowing lava to build the same mountain again and again. Yet the crust is not uniform. It is thicker in the southern highlands and thinner in the northern plains, a global imbalance that may trace back to giant impacts in the planet's youth. Beneath the crust lies the mantle, made of silicate rock, the engine that once drove volcanic activity. Though Mars no longer erupts with fire, the mantle may still be warm, slowly transferring heat outward. Evidence of recent volcanic flows, only a few million years old, suggests the mantle is not entirely quiet. It may still pulse with hidden motion, not enough to split the crust apart, but enough to stir gently, to breathe heat into the planet's bones. At the center lies the core, a sphere of iron, nickel, and sulfur. Unlike Earth's core, which is partly solid and powers a magnetic field, Mars's core seems to be fully liquid, but cooler, unable to sustain the dynamo that once shielded the planet with magnetism. Without that shield, the atmosphere was stripped away. The silence of Mars's surface today begins in its heart, in a core that no longer burns as fiercely, leaving the planet exposed to the sun's relentless wind. We know these things not only by theory, but by listening. InSight, a lander that touched down in 2018, carried a seismometer, a delicate ear, pressed to the Martian soil. For years, it listened to the faint quivers of the planet, tiny Marsquakes that rippled through stone. Some were small, little more than vibrations, while others were stronger, caused perhaps by the cooling and contracting of the crust, or by distant impacts. Each quake was like a bell rung inside the planet, its vibrations carrying information about the layers they passed through. By studying them, scientists traced the thickness of the crust, the depth of the mantle, the size of the core. Mars revealed its interior, not in sight, but in soundless motion. These Marsquakes remind us that Mars, though still, is not dead. It contracts as it cools, the crust cracking under the slow loss of heat. Over eons, the planet has shrunk, leaving behind scarps and cliffs, where the surface buckled. Unlike Earth, where tectonics reshapes the land constantly, Mars changes only subtly, in small, patient increments. Its silence is not emptiness, but a different kind of rhythm, slower and more deliberate than ours. The crust itself holds a history older than Earth's surface. Without tectonics to recycle it, many regions of Mars have remained unchanged for billions of years. Craters preserve the record of ancient impacts, valleys preserve the memory of vanished rivers, and rocks keep the chemistry of waters that disappeared long ago. To study Mars's crust is to peer into the past of the solar system, to see a history that Earth's own restless surface has erased. Sometimes meteorites from Mars find their way to Earth, blasted into space by impacts and falling here as stones. Within them, scientists have found tiny bubbles of trapped gas that match Mars's atmosphere perfectly, proof of their origin. These rocks are windows into Mars's crust, carrying stories across space. Some even hold structures that once sparked debate, microscopic shapes that some thought might be fossils of bacteria. While the evidence remains uncertain, the idea that life's traces could be carried to Earth within Martian rocks adds another layer to the planet's quiet mystery. To imagine standing on Mars is to see only its surface, but to know Mars is to remember that beneath your feet lies a world of stone, mantle, and core. A planet that was once hot, alive with eruptions, and shielded by magnetism, now cooled and quiet, its interior revealed only through faint tremors. Mars's silence is not emptiness. It is depth, a hidden structure that shapes the face we see above. So as you drift further tonight, imagine the slow heartbeat of Mars, a rhythm measured not in seconds, but in ages. The crust holding its scars, the mantle still warm, the core liquid and heavy, quiet but present. Beneath the red deserts lies a planet with layers of history, whispering through Marsquakes, telling us its story in the stillness of stone. Though Mars may seem frozen in time, its surface is not without motion. The silence of its deserts hides the slow, steady work of wind and dust. Sculpting patterns across the land, to walk there would be to step through a world that looks ancient and still. Yet beneath that stillness, the planet is alive with small, patient movements. Mars is a world where the grand forces of rivers and lava have passed, but where the whisper of wind remains, drawing lines and curves upon its face. Dunes stretch across the plains, shaped grain by grain into forms both familiar and strange. Some are crescent-shaped, their arcs pointing away from the wind that carved them. Others stretch into long ridges, undulating across valleys like waves frozen in stone. On Earth, dunes shift with storms, but on Mars they move more slowly, creeping a few meters each year. Rovers have watched them, their shapes changing subtly with time, proving that even in the thin air, the planet still breathes motion. Dust devils dance across the land, twisting columns of air that lift red dust high into the sky. From orbit, they can be seen as dark tracks, etched across the surface, trails left by their passage. From the ground, rovers have filmed them, thin whirlwinds moving silently across the horizon, some towering hundreds of meters tall. Though delicate, they are powerful enough to clear dust from solar panels, as they once did for Spirit and Opportunity, extending their lives. These dust devils are like fleeting spirits, restless dancers sweeping across the plains, erasing and redrawing the surface in their wake. Erosion, too, is at work. Rocks are shaped by the steady blast of sand, carried in the wind, their surfaces polished smooth, their edges carved into strange sculpted forms. Yardangs, long ridges aligned with prevailing winds, stretch like arrows across the desert, testaments to the power of abrasion. Over millions of years, these slow forces reshape entire regions, turning stone into dust, dust into dunes, and dunes into new patterns again. Sometimes the wind reveals as much as it hides. In some craters, Shifting sands expose bright patches of ice buried just below the surface. In others, the retreat of frost leaves behind spider-like patterns carved by gas rushing out from beneath translucent sheets of frozen carbon dioxide. These shapes, unique to Mars, remind us that its surface is not only sculpted by dust, but also by the dance of ice and gas. As seasons change, Mars also shows signs of landslides and avalanches, sudden movements that reshape cliffs and crater walls. Near the poles, dark streaks mark where icy slopes have collapsed in spring, triggered by sunlight thawing frozen carbon dioxide. From orbit, scientists have captured the moments when clouds of dust billow outward, avalanches frozen in time. These events remind us that while Mars may be quieter than Earth, it is not entirely still. Its surface continues to shift, to settle, to collapse under gravity's gentle insistence. There are curious streaks on some slopes called recurring slope lineae, dark lines that appear in warm seasons, lengthen downslope, then fade in the cold. For years, they were thought to be evidence of briny water seeping down hillsides. More recent studies suggest they may be caused by dry processes, perhaps sand avalanches, yet the mystery remains. One more hint that Mars still holds secrets in its restless surface. Even the dust itself is alive with meaning. It coats rocks, fills valleys, and hangs in the air during storms. It is fine, like talcum powder, clinging to everything. This dust is not just debris. It carries the chemical signature of the planet's history: oxidized iron that gives Mars its red hue, perchlorates that affect the chemistry of water, and grains that reflect the long process of stone ground down by time. To touch the dust of Mars would be to hold its past in your hand, the residue of ages of erosion. From orbit, the surface of Mars looks quiet, but with patience, its motions are revealed. Dunes shifting, dust devils spinning, streaks lengthening and fading. Mars is not static. It changes in rhythms too slow for a single glance, but steady over years and centuries. It is a planet that whispers in dust rather than shouts in storms of water and fire. Its life is subtle, its motion patient, but it endures, carrying on the long work of reshaping itself in silence. As you rest tonight, imagine standing on a Martian plain. Around you, dunes ripple into the distance. In the corner of your eye, a dust devil whirls across the land, its shape vanishing as quickly as it appeared. A faint breeze lifts grains of dust, brushing against your suit, carrying the same iron oxide that paints the entire world. The land may seem frozen, but in truth it is alive with motion, small, delicate, and endless. Mars is still at work, sculpting itself grain by grain beneath a pale, quiet sky. At the edges of Mars, where its axis tilts the poles toward and away from the sun, lie vast caps of ice. They gleam white against the red deserts, shining like jewels from orbit. These polar regions are some of the most striking features on the planet, not only for their beauty, but for the secrets they carry. Records of climate, layers of history, and reservoirs of water that connect the Mars of today with the Mars of long ago. In the north lies the larger cap, a spiral of bright ice, stretching more than 1,000 kilometers across. It is made mostly of water ice, permanent and thick, layered over time by snow and dust. Over its surface, darker streaks curve into elegant swirls, sculpted by winds that carve the ice into ridges called troughs. These spirals are like fingerprints, marking the motion of air across the pole for millions of years. From above, the North Polar Cap looks almost like a frozen hurricane, a vast whirlpool of ice spinning silently at the top of the world. The Southern Cap is smaller but stranger. It too has a permanent base of water ice, but its surface is covered each winter by a layer of carbon dioxide that freezes from the atmosphere itself. As the sun returns in spring, this carbon dioxide sublimates back into gas, thinning the ice and filling the air again. Each year, the cap breathes, exhaling carbon dioxide into the sky, then inhaling it back into solid form. It is a cycle unlike anything on Earth, a rhythm tied not to oceans or vegetation, but to the freezing and thawing of air itself. Beneath the surface, the polar caps are layered like the pages of a book. Dust storms and icefalls leave thin lines of sediment and frost, stacked over time into vast deposits called polar layered terranes. Each layer records a season, a storm, a shift in the tilt of Mars' axis. Just as tree rings on Earth reveal climate history, these icy layers hold a frozen diary of Mars's past. By studying them, scientists can glimpse cycles stretching back millions of years, tracing how ice advanced and retreated, how dust swept across the globe, how the planet's climate shifted through ages. Radar from orbit has revealed even more. Beneath the South Polar Cap, reflections suggest buried lakes of liquid water, held in place by salts that lower the freezing point and by the pressure of the ice above. These underground brines, if they exist, would be among the last true bodies of liquid water on Mars today. Dark, cold, and shielded from radiation, they would be alien seas hidden beneath kilometers of ice. They remind us that Mars still holds mysteries beneath its frozen skin, places where life's possibilities may not yet have faded entirely. In the spring, when the carbon dioxide ice at the poles begins to thaw, the land becomes alive with strange patterns. Gas trapped beneath translucent ice bursts free in geysers, carrying dust that fans out across the surface. From orbit, these appear as dark streaks radiating outward, forming shapes that resemble spiders crawling across the ice. These spiders are unique to Mars, sculpted by processes we have never seen on Earth. They are the breath of the planet made visible, the exhalation of a pole waking from winter. The caps also shape the planet's weather. As carbon dioxide freezes and thaws, the air pressure of the entire atmosphere rises and falls, shifting winds and triggering storms. The poles breathe for the planet, inhaling and exhaling air, tying the seasons of Mars to the rhythm of frost and thaw. Without oceans to moderate its climate, Mars is ruled by its poles, its weather a reflection of ice turning to gas and gas turning back to ice. For future explorers, the poles may hold hope. Water ice is a resource beyond price, for drinking, for growing food, for making oxygen and fuel. The caps, vast and accessible, may one day sustain settlements on Mars. But even beyond their utility, they will remain places of wonder. To stand at the pole of Mars would be to see endless fields of white stretching to the horizon, to feel the air thin and biting, to watch the sun circle low in the sky for weeks without rising high. It would be a landscape both alien and strangely familiar, a frozen echo of our own Arctic and Antarctic, but beneath a pale orange sky. So as you rest tonight, imagine drifting across the poles of Mars. Beneath you, layers of ice hold millions of years of memory. Around you, winds carve spirals into frozen seas. Above you, the thin sun glows faintly, scattering through dust and haze. The poles are not only the coldest places on Mars, they are its archives, its lungs, its hidden seas, its promise of water. In their silence lies the record of a planet's life, written in frost and dust, waiting patiently for us to read. Stretching across the face of Mars like a wound too vast to ignore is Valles Marineris, the greatest canyon in the solar system. It is a scar that runs more than 4,000 kilometers from end to end, wide enough to span the distance between New York and Los Angeles, deep enough to hide Mount Everest within its walls. No other canyon known to us compares. If you stood on its rim, the horizon would fall away, dropping into darkness that seems bottomless, the cliffs towering higher than anything on Earth. It is not a crack in stone. It is a world within a world. Unlike the Grand Canyon, carved by a river over millions of years, Valles Marineris was born of stress and rupture. Long ago, the crust of Mars stretched and cracked, perhaps under the weight of the Tharsis volcanic plateau, tearing open vast fractures. Landslides widened them, Erosion deepened them, and over time, the scars grew into chasms. Within them lie valleys, layered with sediments, deposits that hint at water once flowing through these depths. Dry channels and collapsed regions mark places where floods may have surged, brief torrents rushing across stone before vanishing into silence. The canyon is not a single trench, but a system, a labyrinth of valleys, cliffs, and mesas. In some places, the walls step down in tiers, each level a window into deeper layers of Martian history. In others, the floor is littered with landslide debris, enormous blocks the size of mountains that broke free and tumbled into the abyss. Imagine the moment those cliffs gave way, entire landscapes crashing downward in slow motion, filling the valley with dust that would have risen like a veil across the sky. From orbit, the canyon is a gash in the planet's side, visible even from far above. From the ground, it would be overwhelming. Shadows would stretch across kilometers, cliffs fading into haze, the thin sky deepening the sense of scale. To walk into Valles Marineris would be to descend not just into rock, but into time, each layer holding records of climate, of floods, of volcanic ash. It is a library of stone, written in strata stacked over billions of years. Other valleys cross the Martian surface, each with its own story. Outflow channels such as Kosei valleys and Ares valleys are immense, carved by floods of unimaginable force. These channels stretch hundreds of kilometers wide, shaped in moments of catastrophe when water or ice, trapped beneath the ground, suddenly burst free. The flows scoured plains, carried boulders the size of houses, and left behind braided channels that now lie dry and silent. They remind us that Mars, though quiet now, once knew violence, floods on a scale that no human has ever seen. Smaller valleys tell gentler stories. Dendritic networks, branching like the veins of leaves, suggest long-lived rivers, flowing slowly over landscapes, feeding lakes in craters. These patterns are familiar, echoing river systems on Earth. To see them on Mars is to imagine rain falling from thicker skies, streams trickling across hillsides, lakes reflecting sunlight beneath drifting clouds. Even if the planet is dry now, the memory of water runs deep in its valleys, carved into the very bones of the land. Some valleys may still hold hidden ice. Radar surveys from orbit have revealed deposits buried beneath dust, glaciers preserved beneath protective blankets of soil. They are relics of times when ice advanced across mid-latitudes, now hidden but waiting. For explorers, such ice would be treasure, both as a record of climate and as a resource for survival. The valleys of Mars are not just scars. They are vaults, holding both memory and possibility. Valles Marineris itself remains a mystery. Why did it grow so large? Was it solely the weight of Tharsis pulling the crust apart? Or did water play a greater role, seeping through fractures, carving out caverns that collapsed into valleys? The canyon refuses simple answers, its scale too vast, its history too layered. Like Mars itself, it is both explanation and question, both presence and puzzle. Imagine standing at its edge as the sun sets, casting the cliffs into shadow, the sky glowing faintly blue near the horizon. The silence would be absolute, broken only by the whisper of thin winds carrying dust across stone. You would feel small, impossibly small, before walls that stretch into haze, before a canyon that dwarfs even the imagination. And yet, in that vastness, there would be peace, the kind of peace that comes from knowing that you are looking at billions of years of history, written in cliffs that rise higher than mountains, in valleys that stretch farther than seas. So as you rest tonight, picture Valles Marineris not only as a scar, but as a monument to forces that tore a planet apart, to floods that carved the land, to time that layered stone upon stone. It is a canyon like no other, a reminder that even in silence, a world can speak with depth and power, its voice carried not in sound, but in shape. If the canyons of Mars are scars of fracture, then its volcanoes are monuments of fire. Rising above the plains, they tell of a planet that once burned with energy, pouring molten rock across its surface. Today they are silent, their craters cold, but their size alone reminds us of what Mars once was, a world that could give rise to the tallest mountains in the solar system. The greatest of them all is Olympus Mons. It rises 22 kilometers above the surrounding plains, almost 3 times higher than Mount Everest. Its base is vast, more than 600 kilometers across, so wide that if you stood at one edge, the horizon would curve away before you could glimpse the other. Its slopes are gentle, so broad that you might not even realize you were climbing a mountain. Yet the summit caldera, a complex of collapsed craters, is large enough to swallow cities. Olympus Mons is not simply a mountain. It is a world upon a world. Unlike Earth's volcanoes, which are built by shifting plates that carry hotspots across the crust, Mars's crust is fixed. This stillness allowed magma to rise again and again through the same channels, piling lava layer upon lava, until the mountain grew to impossible heights. For hundreds of millions of years, Olympus Mons erupted, not in explosive bursts, but in slow floods of basaltic lava. The flows spread outward like cloth laid over a table, building the shield that remains today. Around Olympus Mons lies the Tharsis region, a volcanic plateau that reshaped the entire planet. Here rise Arsia Mons, Pavanes Mons, and Ascraeus Mons, each nearly as tall as Everest, aligned like giants in a row. Together they form a chain that may have influenced the entire crust, tugging it, cracking it, and helping to open Valles Marineris. The weight of Tharsis alone is thought to have shifted the balance of the planet, altering its tilt and reshaping its climate. These volcanoes are not just mountains, they are architects of the world itself. To the east lies Elysium Mons, another shield volcano, smaller than Olympus, but still dwarfing anything on Earth. Its flanks are carved with lava flows and channels, records of eruptions that may have occurred as recently as a few million years ago, the blink of an eye in planetary time. Some scientists believe that Mars may not be entirely extinct volcanically. Beneath the crust, pockets of magma may still linger, quiet but not gone. If so, Mars is not only a world of memory, but of potential, still carrying the spark of fire within. The volcanoes also shaped the planet's air and water. In their prime, they would have released vast amounts of gas, carbon dioxide, water vapor, sulfur. These eruptions may have helped thicken the atmosphere, warm the surface, and create the conditions for liquid water. In this way, volcanoes were not just mountains, but climate makers, breathing life into the air and sustaining rivers and lakes that flowed across the plains. Their silence today is part of why Mars is thin and cold, for the planet no longer exhales the gases that once warmed it. The slopes of these volcanoes hold more than geology. They hold possibilities. Lava tubes, long caves formed as lava flowed and hardened, may stretch for kilometers beneath the surface. These tubes, shielded from radiation and temperature extremes, could provide natural shelters for future explorers. They are empty halls carved by fire, waiting in silence for footsteps that may one day echo within them. From orbit, the volcanoes look like titans, their broad shapes dominating the surface. From the ground, they would be overwhelming, slopes rising so gently that the summit would always feel far horizons stretching endlessly upward, the air thinning in silence. To stand on Olympus Mons would be to stand higher above the surface of a planet than anywhere else in the solar system. The view would not be of seas or forests, but of endless desert canyons at the edge of sight, and the thin sun glowing faintly in a pale sky. And yet, there is peace in these giants. Their fires are long extinguished, their slopes eroded by winds rather than lava. They are reminders that planets age, that fire gives way to silence, that worlds too have lifespans. Once, Mars burned with heat. Now, it rests, its volcanoes vast but quiet, their voices stilled. So as you drift further into rest, imagine walking across the flank of Olympus Mons, each step carrying you across a mountain so vast that its slopes seem endless. Imagine the horizon curving, the summit lost in distance, the silence profound. These are not mountains of this world, they are mountains of time, monuments to a past of fire, waiting quietly beneath the stars. The surface of Mars is marked by countless circles, scars left by impacts across billions of years. Each crater is a memory of a moment when the quiet planet was struck by stone from the sky, when asteroids or comets slammed into its crust with unimaginable force. Unlike Earth, where oceans, forests, and shifting plates erase such marks, Mars has preserved them. To walk across its plains is to walk across a record of cosmic bombardment, every hollow and rim a page in the long diary of the solar system. The largest of these scars is Hellas Planitia, a basin so vast it could swallow nations. More than 2,000 kilometers across and 9 kilometers deep, it was created by an impact so powerful that it reshaped not just the surface, but the atmosphere above it. The floor of Hellas is one of the lowest places on Mars, a depression where air pressure is slightly higher than elsewhere. From orbit, it looks like a pale oval carved into the red filled with dust and frost. To stand within it would be to stand in a world within a world, the horizon rising all around you, as if you were at the bottom of a bowl. Another enormous basin is Argaea Planitia, nearly as wide, ringed by mountains formed by the force of its creation. Around its edges, valleys and channels suggest that water once flowed into the basin, perhaps filling it with a great lake. If so, Argaea may have been one of the largest bodies of water on Mars, a sea created by violence but sustained by rivers. Today, it lies dry, its floor filled with dust and craters, but its shape still whispers of the floods that once touched its rim. Smaller craters cover the planet in uncountable numbers. Some are fresh, their rims sharp, their ejecta blankets spreading outward in rays of brighter soil. Others are ancient, softened by wind and time, their edges eroded, their floors filled with sand. Some hold central peaks, mountains that rose from the rebound of the crust after impact. Others contain layered sediments, deltas, or earths, transformed long after their violent birth. Each crater is more than a scar. It is a landscape, a feature that holds both destruction and the possibility of preservation. In some craters, ice still lingers. Radar from orbit has revealed frozen deposits beneath the dust, layered like hidden reservoirs. In others, signs of ancient lakes remain, shorelines, sediments, and minerals that formed in standing water. These craters may have been oases, places where life could have found refuge if it ever existed. Jezero Crater, where Perseverance rover now explores, was once one such lake. Its ancient delta still curves outward, a fossil of water's touch, holding rocks that may preserve the faint traces of microbes that swam in Martian waters long ago. Impacts also gave Mars its moons. Some scientists believe Phobos and Deimos may be captured asteroids, but another theory holds that they formed from debris, thrown into orbit by a massive impact, much as Earth's moon was born. In this way, the violence that scarred the surface may also have created the companions that still circle above. Not all impacts are ancient. Even today, Mars is struck by meteors, leaving fresh craters that orbiters can watch appear. Dark streaks mark where soil has been overturned, and in some cases patches of ice are exposed, gleaming briefly before fading. These fresh scars remind us that Mars is not frozen only in time, but still alive in change, its surface still shaped by the sky. The density of craters also tells us the age of regions. The heavily cratered highlands are ancient, formed more than 3 billion years ago. Their surface is unchanged since the early days of the solar system. By contrast, the smoother plains of the north are younger, resurfaced by volcanic flows and floods that erased older marks. By counting craters, Scientists read the relative ages of surfaces, mapping time across a planet's skin. And yet, for all their violence, craters hold a quiet beauty. From orbit, their circles form patterns across the land, overlapping like ripples in stone. On the ground, their walls rise like cliffs. Their floors stretch into vast plains. Their shadows deepen with the setting sun. Some are filled with dunes, others with frost, others with silence alone. They are reminders that destruction and creation are bound together, that even in violence, landscapes are born. As you drift further into rest, imagine walking across the floor of Hellas Planitia, the horizon curving upward, the walls invisible in the haze of distance. Imagine climbing the rim of a smaller crater, standing at its edge, and looking into a hollow carved by an instant of fire. Imagine dust settling after an impact, the silence returning, the planet absorbing another memory. Mars is a world of scars, but also of stories. Each crater, a chapter in its long and patient history. Above the stone and dust of Mars lies a sky that seems fragile, almost an afterthought. Its atmosphere is so thin that it would feel like standing at the edge of space on Earth, a pressure less than 1% of what we breathe. And yet that thin air is enough to paint the sky butterscotch, enough to scatter sunlight into blue at sunset, enough to carve dunes and carry storms that wrap the entire planet. Mars's sky may be fragile, but it is not empty. Most of its air is carbon dioxide, with only traces of nitrogen and argon, and barely a whisper of oxygen. It is not air we could breathe, but it is air that still moves. Each winter, carbon dioxide at the poles freezes into ice, pulling pressure out of the atmosphere until the whole planet breathes shallower. In spring, the ice sublimates back into gas, swelling the atmosphere again. The planet inhales and exhales with the seasons, its air pulsing in rhythm with the tilt of its axis. Even in its thinness, the atmosphere carries dust. The surface is covered in fine particles of oxidized iron, and the slightest breeze can lift them. Dust devils twist upward into the sky, swirling columns that march across the land, leaving dark trails behind. These whirlwinds are common, rising in silence, some as tall as mountains. From the ground, they would look like wandering ghosts, slender and shifting, fading almost as quickly as they appear. From orbit, their tracks mark the land with scars of motion, proof that even in stillness, Mars is alive. But sometimes the dust does not dance. Sometimes it devours. Every few years, local storms swell into regional ones, and regional storms grow until the entire planet is wrapped in a glowing shroud. The sun disappears, the land vanishes into haze, and the world becomes a sphere of swirling red. These storms can last for months, their winds strong enough to lift dust higher than the tallest volcanoes. Though the atmosphere is too thin to crush with force, the scale of the storms is overwhelming. For rovers on the surface, darkness falls, solar panels are buried, and silence grows. Opportunity, after more than a decade of exploration, fell quiet in one such storm, its voice fading beneath the dust, never to return. The winds of Mars are restless. They carve dunes into shifting waves, sculpting crescents that march slowly across valleys. They polish rocks, etch ridges, and move grains across plains in endless cycles. Though the atmosphere is thin, the persistence of time makes it powerful. Grain by grain, year by year, Mars winds reshape its deserts, leaving patterns we can read from orbit like writing across the land. The temperature swings are sharp. Without a thick atmosphere to hold heat, days may rise above freezing only to plunge to -60 degrees at night. In the coldest places, near the poles, it falls below -100. Heat escapes quickly into space, leaving the nights clear and sharp, stars burning brightly in the thin air. At dawn, frost forms, delicate coatings of ice that vanish with the sun, reminding us that even in the desert, water and air still play their quiet game. Clouds drift across this sky, though they are faint and rare. made of water ice or carbon dioxide. They form thin veils that spread across horizons, sometimes streaking in delicate lines, sometimes gathering in ripples. In spring and summer they can gather near volcanoes, forming orographic plumes, long tails of cloud trailing downwind, like banners stretched across the sky. In the evening, these clouds catch the fading sunlight, glowing softly before dissolving into darkness. The atmosphere also carries mysteries. Methane has been detected in small bursts, rising and fading unpredictably. On Earth, methane often comes from life, but it can also come from chemistry in rock. Its presence on Mars is a question unanswered. Is it the breath of geology or the faint whisper of biology? Whatever the source, it proves that even now, Mars's air is not static. It is active, dynamic, alive with processes we do not fully understand. If you were to stand on Mars, the sky would feel at once familiar and alien. It would arch above you in pale gold, dimmer than Earth's, with a faint haze softening the horizon. At sunset, the horizon near the sun would glow blue, while the rest of the sky deepened into copper. The wind would brush dust across your boots, whispering faintly, the only sound in an otherwise absolute silence. You would know that the air around you was thin and unbreathable, but you would also feel its presence, its ability to move, to sculpt, to hide, and to reveal. So as you rest tonight, imagine the thin breath of Mars. Imagine its seasons, its storms, its dust devils rising like ghosts, its sunsets painted in reverse colors. Imagine the silence broken only by the whisper of air moving across stone. The atmosphere may be faint, but it is the veil that ties the planet together, the breath that has carried it from its past of rivers to its present of deserts. Mars still exhales, and in that breath lies its story. On clear nights when the sky is dark and the stars are sharp, Mars glows like a steady ember among them. Unlike the twinkling lights of distant suns, Mars shines with a steadiness that marks it as something closer, something within our own solar family. Its color, rusty orange, sometimes golden, makes it unmistakable. You can trace its path across the heavens, moving from one constellation to another, its journey slow but perceptible over weeks. It is not a star, it is a neighbor wandering through the sky with us. Every 2 years or so, Earth and Mars draw especially close, circling the sun in their separate lanes until they align. These moments are called oppositions, when Mars rises as the sun sets, glowing at its brightest in the midnight sky. During opposition, the planet can be seen with the naked eye in astonishing clarity, brighter than almost anything else in the heavens. Across history, these moments stirred awe as Mars swelled in brilliance, a fiery jewel hanging above fields, deserts, and oceans of Earth. Telescopes revealed more, of course, but even without them, Mars has always been a constant in human eyes. To ancient stargazers, it was a wanderer with purpose, its retrograde loops across the heavens puzzling and inspiring. To us now, it is the reminder that planets are companions, that Earth is not alone in circling the sun. When you look at Mars, you are looking not at a distant star, but at a world, a place of mountains, canyons, and deserts, orbiting the same star you do. That realization makes the night sky feel closer, more intimate. Our connection to Mars is more than visual. We have reached out to it with machines, closing the gap of millions of kilometers with spacecraft. Rovers roll across its deserts, orbiters trace its storms, and landers rest upon its plains. From Earth, we speak to them across a gulf of light minutes, and they answer back, their signals faint but steady. When we see their images, we see Mars through borrowed eyes, horizons beneath copper skies, rocks scattered across dust, shadows stretching long at dawn. These images are not imagination. They are real, direct visions of another world, sent to us across the void. And when meteorites fall to Earth, they sometimes carry pieces of Mars itself. Launched by ancient impacts, these rocks traveled through space until they landed here. Scattered across deserts and ice fields, scientists study them, cracking them open to find gases trapped inside, their composition matching Mars' air. In this way, fragments of our neighbor have already touched our world. Earth and Mars are not only connected by sight, but by stone, by matter exchanged across space. There is a strange intimacy in this closeness. Venus may orbit nearer, Jupiter may shine brighter, but Mars feels more like kin. Its day is like ours, its seasons are like ours, its landscapes are shaped by familiar processes, even if they have long gone quiet. When we imagine life beyond Earth, Mars is always the first step, not because it is easy, but because it is reachable, relatable, within the scope of human longing. Mars has been both mirror and dream. In its redness, we have seen omens of conflict. In its imagined canals, we saw civilizations of our own making. In its silence, we now see the possibility of survival, of expanding human presence. Every generation has found something of itself in Mars, whether myth, fear, or hope. It reflects us, even as it reveals itself. If you step outside and look up when Mars is bright, you may feel that connection. The light that reaches your eye has crossed millions of kilometers, reflected off dust and stone. It carries with it the story of a planet that circles the sun beside you, following its own rhythm, yet bound to the same star. To see it is to know that we are part of a family of worlds, each with its own story, each with its own fate. So as you drift deeper into rest, imagine Earth and Mars circling the sun together, two worlds side by side, one blue and alive, the other red and silent, yet both turning endlessly, their paths weaving through time. When you see Mars in the sky, you are not just looking at light, you are looking at a world that waits, a world that remembers, a world that has always been with us in the quiet of night. The thought of walking on Mars has haunted human imagination for generations. We have written it in stories, drawn it in art, and dreamed it in science. To imagine a person stepping down onto Martian soil, leaving a footprint in the red dust, is to imagine the continuation of humanity's long voyage outward, begun when our ancestors first crossed rivers and seas on Earth. Mars is the next great shore, and yet, it is a shore unlike any other, distant, harsh, and silent, waiting patiently for us to arrive. The journey itself is immense. Depending on the alignment of the planets, Mars lies between 50 and 400 million kilometers away. A voyage there would take months, half a year or more. Through the emptiness of interplanetary space, astronauts would live in cramped quarters, carried by engines that burn steadily for weeks, guided by trajectories calculated to meet a moving world. They would see Earth shrink into a bright star, the moon fade behind them, and Mars grow slowly in the blackness, first as a point of light, then a disk, then a horizon. Landing would be no less daunting. Mars's thin atmosphere provides little cushion, too faint to slow a spacecraft as Earth's does, yet too thick to ignore. To reach the ground, explorers must combine heat shields, parachutes, rockets, and perhaps even giant inflatable shells or sky cranes, balancing against the gravity that pulls them down. Every mission we have sent so far has tested this dance of entry, descent, and landing, and each success has been a marvel of precision. But to bring humans safely through that descent will demand both courage and invention. Once on the surface, the challenges deepen. The air cannot be breathed. The temperature falls far below freezing. Radiation from the sun passes easily through the thin sky. To survive, habitats must be strong and sealed, shielding settlers from the elements. They would carry their air with them, recycle their water endlessly, grow food in greenhouses lit by lamps and sunlight filtered through glass. Every necessity of life on Earth would need to be manufactured anew, drawn from the Martian soil, the ice beneath the ground, the carbon dioxide in the air. And yet, With these challenges comes wonder. To step onto Mars would be to see a horizon no human eye has ever witnessed. To watch the sun rise through a butterscotch sky. To see Phobos race overhead and Deimos drift like a star. To stand on the rim of a crater carved by an ancient impact. To climb the flank of a volcano that towers higher than any mountain on Earth. To look across canyons so vast that they stretch into haze. Every step would be discovery. Every view would be history. For those who go, Earth would always remain above them, as a bright point in the sky. Unlike the Apollo astronauts who looked back at Earth as a great glowing marble, Martian settlers would see it as a star, pale blue, shimmering among countless others. To look at it would be to feel both distance and connection, the ache of homesickness and the pride of knowing they had carried Earth farther than ever before. The first words spoken on Mars will echo through human history, as Neil Armstrong's did on the Moon. They will not belong only to the astronaut who speaks them, but to all of us, for they will mark the moment when humanity became a multi-planetary species, when we reached beyond our cradle and touched a new world. The dust of Mars will cling to boots and suits. It will be carried into airlocks and brushed from tools, and in that dust will lie the symbol of a dream realized. But Mars is not only about symbols, it is about science, about the chance to hold in our hands the rocks of river deltas, the layers of sediment that may contain fossils of microbes, the buried ice that may tell of ancient seas. To send humans to Mars is to give us not only presence, but touch, the ability to dig, to climb, to see with eyes that can choose in the moment where to step and what to study. No machine, no matter how clever, can replace the intuition of a human hand on alien stone. The journey will be dangerous. The landing will be hard. Life on Mars will be fragile, surrounded by silence and risk. But in that fragility lies meaning. To live there would be to live always with awareness of how rare life is, of how dependent we are on air and water, of how precious Earth remains, even as we build a second home. Mars is not a replacement. It is a reminder, a challenge, and a promise that we can carry life farther. So as you let your thoughts slow, imagine the hum of engines, carrying explorers across space. Imagine the heat of entry, the parachutes opening, the dust rising as rockets lower a craft to the surface. Imagine the hatch opening, a ladder descending, a figure stepping out onto red soil, the first footprint pressed into dust that has waited for billions of years, the silence broken only by a voice carried through radios across the void. It is a dream now, but dreams, like footsteps, begin small and grow as we follow them. Mars is not only a neighbor in space, it is a window into time. Unlike Earth, which remakes itself constantly through oceans, weather, and the shifting of plates, Mars has remained still for much of its life. Its crust does not recycle. Its surface changes only slowly. Its scars linger. In this stillness lies memory. Mars is a time capsule, preserving what Earth has long since erased. By studying it, we read the story of the solar system's youth, of the conditions that shaped both our worlds. The southern highlands are among the oldest landscapes we can see anywhere. They are heavily cratered, their surfaces unchanged for more than 3.5 billion years. On Earth, no such surfaces remain, for wind, water, and tectonics have wiped them away. But on Mars, these plains endure, a frozen portrait of the bombardment that once rained down on all the inner planets. By counting craters, by tracing their overlaps, scientists reconstruct a timeline of impacts, a record of violence written in circles of stone. Craters are not only scars, they are archives. Their walls expose layers of rock otherwise buried. Their floors preserve sediments carried by wind and water. Their ejector blankets reveal what lies beneath the surface. In some, ice remains hidden, protected from sunlight for millions of years. In others, deltas and shorelines are fossilized in stone. reminders of ancient lakes. To explore a Martian crater is to open a book whose pages have never been turned. Each layer tells a story of climate, of chemistry, of time. Mars also keeps the memory of water. Minerals in its rocks, clays, sulfates, carbonates, formed when water once soaked the land. These minerals have endured for billions of years, untouched by later floods or shifting crust. They hold within them the conditions of their birth, like sealed letters waiting to be read. To hold a piece of Martian clay would be to touch the chemistry of a lake that dried 3 billion years ago. To feel in your hand the record of an environment that once might have welcomed life. The polar layered deposits are another archive. Year by year, frost and dust settle at the poles, stacking into bands that can stretch kilometers thick. Each band is a record of climate, of seasons, of storms, of the tilt of Mars' axis as it wobbled over ages. Just as tree rings reveal the years of a forest, these icy rings reveal the years of a planet, frozen layers of memory, stretching deep into time. When radar pierces them, we glimpse patterns of advance and retreat, of warmth and cold, of a climate that has shifted many times before. Even the lack of change is meaningful. On Earth, rocks are transformed by water, life, and motion. On Mars, they remain closer to their original state. Some Martian meteorites that have landed on Earth are more than 4 billion years old, carrying the chemistry of the early crust. They are samples of a world that has not forgotten its beginning. They remind us that Mars holds answers to questions Earth has long since covered with oceans and forests. In this way, Mars connects us to our own past. To study it is to see what Earth might have looked like in its first billion years, before continents drifted, before oceans stabilized, before life spread widely. Mars is a mirror of our beginnings, showing us not only what could have been, but what was, the raw conditions that shaped both worlds, side by side, under the same young sun. And so, when rovers drill into stone or scoop at soil, they are not only studying Mars, they are studying the earliest chapters of the solar system. They are looking back across billions of years, into a time before Earth carried forests or oceans, into the silence of a world just beginning. Mars may not have life now, but it carries the record of whether life could have begun, whether chemistry once stirred into biology beneath its ancient skies. As you close your eyes, imagine Mars not as a frozen desert, but as a library, each crater a chapter, each valley a sentence, each layer of ice a page written by time. The book is vast, its language subtle, but it waits patiently, untouched for billions of years, until we learn to read it fully. To explore Mars is to read the past of not only one planet, but of two. For in its stillness, Mars has preserved the memory of Earth's earliest dawn as well. Mars is not alone in its journey around the Sun. It is one of a family of planets, each tracing its orbit with silent regularity, each carrying its own story of stone, gas, or ice. To understand Mars, we must also see where it belongs, between Earth and Jupiter, at the threshold between the inner rocky worlds and the giant planets beyond. It is a borderland, a world poised between familiarity and vastness, between the small and the immense. Mars circles the Sun at a distance of about 228 million kilometers, nearly 1.5 times farther than Earth. Its year lasts almost twice as long, 687 Earth days. As it traces a wide oval through space, its orbit is more eccentric than Earth's, bringing it closer to the Sun at times and farther away at others, a difference that shapes its seasons and its climate. In its rhythm, we see both similarity to Earth and subtle difference, enough to make it familiar, yet distinctly its own. To its inward side lies Earth, blue and vibrant, our home, close enough that Mars sometimes appears bright and near in the night sky. To its outward side lies the asteroid belt, a vast swarm of rocky bodies that never formed into a planet, their growth stunted by the gravity of Jupiter. Mars is like a sentinel at the edge of this belt, small enough that some scientists wonder if it too was prevented from growing larger by Jupiter's influence. It may be a half-formed world, a planet whose growth was interrupted, left smaller and lighter than its siblings might have been. Jupiter itself, the giant of our solar system, shapes Mars's destiny in subtle ways. Its immense gravity perturbs orbits, stirring asteroids into paths that sometimes cross Mars and Earth. In this way, Mars is more exposed to impacts than Earth, its scars bearing witness to collisions stirred by a giant far beyond. Jupiter may shield the inner planets from some threats, but it also sends others inward, and Mars lies in their path. The craters across its surface are part of this story, reminders of its position in the solar system's delicate balance. Mars also shares resonances with its neighbors. Its moons, perhaps captured from the asteroid belt, remind us of its closeness to that realm. Its iron-rich surface, oxidized into red, mirrors the asteroid's chemistry, and its thin atmosphere, stripped by solar wind, reveals its vulnerability in this place between Earth's protection and Jupiter's pull. Mars is shaped not only by itself, but by where it lies, caught between the warmth of the inner system and the cold expanse beyond. Even the tilt of Mars, its seasons and climate, may have been influenced by gravitational tugs from its neighbors. Unlike Earth, stabilized by a large moon, Mars has only Phobos and Deimos, too small, hold its axis steady. Over millions of years, its tilt has wandered more wildly, swinging from gentle to steep. These shifts would have transformed its climate, moving ice from pole to mid-latitudes, reshaping its face. In this way, Mars's vulnerability to its environment is written not only in its air and water, but in the slow dance of its orbit and tilt, influenced by the company it keeps. Seen from afar, Mars is a modest world, smaller than Earth, larger than Mercury, dwarfed by Jupiter, but it holds a special place in the solar system. It is the only other rocky planet where we see valleys carved by rivers, volcanoes taller than mountains, polar caps gleaming with ice. It is the only place where we can imagine standing and feeling something familiar, a sunrise, a horizon, a season shifting with time. It may not be the largest or the brightest, but it is the one that feels closest to us, in spirit, a bridge between Earth and the wider cosmos. From Earth's sky, Mars appears as a wandering ember, but from space, it is a red sphere among others, part of a family bound to the same sun. Mercury races closer to the fire, Venus shrouds itself in cloud, Earth glows blue, Mars glows red, and beyond them rise the giants, Jupiter and Saturn, with their swirling storms and moons. Together they orbit, each following its path, each carrying its fate. Mars is one member of this family, distinct but bound, turning endlessly in the quiet ballet of the solar system. So as you rest tonight, imagine the view from above the sun, planets circling in graceful ellipses, Earth and Mars drawing close, then drifting apart again in their cycles. Imagine Mars not alone, but part of a greater design, one world among many, each with its own story. Mars is ours to explore, but it is also part of something larger, the quiet harmony of a solar family that has turned for billions of years and will continue to turn long after we are gone. When we look at Mars today, we see a frozen desert, a thin sky, a silence broken only by wind. But when we look at Mars tomorrow, we see possibility. For as long as we have known it, Mars has been a mirror for our imagination, a place where we project not only questions about the past, but dreams of the future. It is more than a planet, it is a horizon, and horizons, by their very nature, call us forward. The first steps may be small. Human explorers, staying for weeks or months, building shelters of metal and glass, testing the ground, drawing water from buried ice, pulling oxygen from the thin carbon dioxide air, greenhouses glowing under pale skies, recycling systems humming, habitats warm against the cold. Each structure would be a seed, planted in red soil, fragile, but alive. And like all seeds, it would carry the potential for growth. From there, colonies may rise. They would not spread quickly, but gradually, carefully, as humans learn to adapt to a world that does not welcome them. Domes of transparent material could shield plants, providing food and oxygen. Habitats carved into lava tubes might protect settlers from radiation, their walls echoing with voices and laughter. Solar panels would stretch across the plains, catching the sun's light. Rockets would come and go, carrying supplies, carrying people, carrying the threads of a growing story. Some dream even further, of terraforming, reshaping the planet to make it more like Earth, thickening the atmosphere by releasing carbon dioxide trapped in soil and ice, warming the air until water flows again, until rivers return to valleys and lakes fill craters, seeding the land with hardy plants, with microbes that prepare the soil for more. It is a dream immense in scale, one that may take centuries, perhaps millennia, but it is a dream that persists. For to imagine a living Mars is to imagine that humanity has become more than earthbound, more than temporary. Even without full transformation, Mars may one day hold vibrant human outposts. Cities beneath domes, communities connected by tunnels and transport, research stations buzzing with discovery. Children born there would know two skies, the pale butterscotch of Mars and the blue remembered in stories of Earth. They would leap higher in the weaker gravity, play in spacesuits, grow up with horizons unlike any seen before. For them, Mars would not be a dream. It would be home. And through it all, Earth would remain in the sky. A pale blue star, small but bright, always visible to remind them where they came from. Mars would not replace Earth, for nothing can replace the cradle of our life, but it would honor it, a second branch of humanity's tree, proof that life can spread, adapt, and endure. For scientists, the future on Mars means more than survival. It means discovery. With human hands and minds on the surface, the search for life, past or present, would gain new depth. Fossils in stone, organics in sediment, microbes in brine. If they exist, they may one day be found. And if they are not, then that silence too is profound. For it would tell us something about the rarity of life, about the uniqueness of Earth, about how precious our home truly is. For dreamers, Mars is more than science. It is a symbol. It is proof that horizons can be crossed, that we can go farther than we thought possible. It is a promise that when Earth faces its own challenges, we will not only endure here, but reach outward as well. To live on Mars is to say that humanity belongs not only to one planet, but to the cosmos. As you drift tonight, imagine this future. Imagine domes glowing in the Martian twilight, corridors filled with voices, farms of green stretching beneath glass. Imagine rockets lifting from the surface, their engines glowing against the thin sky, carrying settlers back and forth. Imagine children pointing at Earth as it shines above them, hearing stories of oceans and rain. Mars will always be red, but in our dreams, it may one day carry the green of life and the light of human presence. It is a dream distant, perhaps centuries away, but dreams are seeds, and Mars has always been fertile soil for them. Whether we remake it or simply live within its bounds, Mars will shape the next chapter of our story. A world once silent, given new voices, a desert once empty, carrying the weight of human hope. And so, after rivers and volcanoes, canyons and craters, after winds and storms, myths and machines, we arrive at the quiet heart of Mars, a world that has been with us always, shining red in the night sky, carrying stories older than humanity itself. It has been a god of war, a canvas for dreams, a desert of silence, and a beacon of hope. It is all of these at once, myth and memory, science and possibility, a planet that waits, patient, just beyond our reach. To speak of Mars is to speak of time. Billions of years carved into stone, floods that came and went, ice that advanced and retreated, fire that rose and faded. It is a planet that remembers what Earth has forgotten, a library of the early solar system written in rock and dust. In its silence, Mars carries not emptiness, but history, a patient record that endures while seas dry, while skies thin, while ages pass. To dream of Mars is to dream of ourselves. We see in it the fragility of climate, the possibility of life, the endurance of stone, the promise of horizons. We imagine walking across its plains, building homes beneath its sky, planting seeds in its soil. We imagine it not only as it is, but as it might be, as we might shape it. Mars is not only a place, it is a mirror, a challenge, a reminder of how far we can reach and how precious our own world remains. And in the end, Mars is quiet. No rivers flow, no forests whisper, no oceans roar. Only the winds sigh, only the dust drifts, only the moons rise and fall. It is a silence deep enough to hear your own breath, to feel the rhythm of your own heart. To stand on Mars would be to stand in that silence, to know that you are small, but also part of something vast, a universe of worlds, each with its own song, each waiting to be heard. Tonight, as you rest, imagine Mars above you, a faint ember in the sky. Imagine its deserts, stretching endless beneath a thin sun, its canyons carved deep, its poles gleaming with ice. Imagine rovers rolling patiently, orbiters circling silently, dreams of footsteps still to come. Mars turns slowly, quietly, carrying its story forward, one day, 1 year, one age at a time. And now, let your thoughts soften, like dust settling after a storm. Let your breath follow the rhythm of Mars's seasons, slow and steady. Let your body grow light, as if you too have stepped onto a world with gentler gravity. You are drifting now, across valleys and plains, across silence and stars. The ember fades, the night deepens, and Mars, ancient and patient, keeps turning. You are part of that turning, part of that silence, part of the story that stretches from Earth to the red world beyond. Rest now within it. Sleep softly and dream gently beneath the quiet skies of Mars. At skies of Mars, 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 at skies of Mars.